All right, it seems like we've reached saturation in the room, so I'll get started so we don't push the schedule back a little bit too far. Hello, everybody. My name is Richard Pyle. I consider myself a fish nerd. The guy who coined that term I see is in the room here today. So I'm going to give you just sort of an overview of who I am, what I do, what brought me to Rebreathers, and then spend the second half of my presentation just sort of talking a little more, wax philosophically about what we've learned over the years doing these kind of dives and where I think our community ought to be heading next. So if you've ever seen me give a presentation on this stuff before, you've seen this slide. It basically shows a schematic of a coral reef environment. I'm a coral reef guy. I'm interested in coral reef fishes. The standard explanation is that conventional scuba gets us down to some depth. You could argue about what that depth is. 50 meters-ish seems about the limit of practical scientific research using conventional scuba gear. Submersibles and other things like ROVs go much deeper than that. They actually almost always go much, much deeper than that, deeper than about 150 meters, 500 feet. So it becomes pretty obvious there's this zone in between that's deeper than where scuba divers go and shallower than where most people take submarines. And in fact, we may know more about the ocean floor than we know about this zone in the middle, which in the beginning we started calling the twilight zone, which seemed like the perfect name for it because it's the transition between the brightly lit shallow reefs and the perpetually dark abyssal depths, and it was great. But unfortunately, that term was used to refer to a deeper zone out in the middle of the ocean, and so there was some confusion. So we decided not to call it that. We started calling them deep coral reefs, which worked really great until they started researching these truly deep coral reefs, thousands of feet deep, cold water deep reefs, and then that community started referring to their habitats as deep coral reefs, so more confusion reigned. So then we just didn't know what to call it. We started calling it deeper portions of typical shallow coral reefs, which was a bit of a mouthful, so leave it to the U.S. federal government to come to the rescue and introduce the term mesophotocoral ecosystems. So we've gone from twilight zone to the mysteries of the mesophotocoral ecosystems, which is much harder to grant money around. I'm not sure what to call it anymore. I guess we'll call it that for the time being. But the point is, my main passion in life has always been to fill in those question marks, to see what lives on coral reefs deeper than where the history of conventional scuba exploration is focused. Now, the obvious way one would think to go about doing that would be to use a submersible. That's what these submersibles are designed for, these research submersibles. Problems with the submersibles, first of all, they cost something on the order of $30,000 to $40,000 a day, which a young undergraduate student generally doesn't have access to those kind of fundings. But even if you did have that funding to use submersibles on deep coral reefs, as we have actually done, there's another limitation too, which is that you're trapped inside this big metal sphere looking through a tiny little porthole trying to study very cryptic coral reef habitat. So I've done 8-hour dives in submersibles, and I spent most of those 8 hours wishing I was outside the sub, trying to see what's just inside that hole or just under that ledge or just inside that cave. So even if we had the money, and we have had the money to do submersible research, that imposes its own limitations for exploring this twilight zone deep coral reefs. So as a brilliant young undergraduate, and it's very obvious how brilliant I am in this photo, I set about trying to figure out how I wanted to explore this zone. And my hero and mentor at the time is this fellow here. His name is Jack Randall. That's not a rebreather he's got on. That's actually a double hose regulator. He started scuba diving in 1946, which is Cousteau's introduction of scuba to the rest of the world. He is the uber fish nerd. He's the most prolific ichthyologist alive today. He's the most prolific ichthyologist for coral reef fishes in the history of the world, which actually says a lot. And the reason he was so successful is that he came around in his career at around the time of the invention of scuba. He was the first person to use this technology to explore coral reefs, and he's found hundreds and hundreds of new species of fishes as a result of that. So I got to know him fairly well when I was young. He was my mentor, and I ended up living in Pyle when I was 19 years old, and this photograph was taken by him. This was taken by Jack Randall in Pyle when I was 19, and I was doing great fun and adventurous things. But as some of you may know, 2 days after this photograph was taken, I was quadriplegic from a very serious case of decompression sickness, and that had a very profound effect on how I decided to go about doing this. I realized that using regular air scuba to go down to those kind of depths beyond the conventional ways was probably not the best way to do it. So I got clever, and I started thinking about high-tech diving. And this rig was actually used to go to 90 meters in our very early days. I wasn't wearing it at the time. But as many of you, I'm sure, know, what it looks like on the outside doesn't matter so much. What matters is what's inside those tanks. It wasn't air. It was a mixture of trimix in one and nitrox in another. But this, as successful as it was in our first attempt to do this kind of stuff, we knew there had to be a better way. So I started sort of researching how do you go about doing this stuff, thinking about it some more. And I came across this fellow, Dr. Bill Stone. I read an article in the Explorer's Journal about him using all this sort of mixed gas technology to explore caves at the same depths that I was interested in exploring. So I contacted him, and through his book, basically became my textbook, and he became my correspondence course teacher in mixed gas diving. I got a little bit more sophisticated about doing this open circuit mixed gas diving stuff, and built this rig, which I used out in Hawaii fairly successfully. This is one of our first mixed gas operations in the Cook Islands, 300 feet deep, catching fish, doing a really good job. It worked out very, very well. But the problem, of course, was we were limited in our bottom time. Even with 4 scuba tanks and 5 regulators and some 200 pounds of equipment on my back, I was still limited to only about 10 minutes of effective bottom time down at 300 or 400 feet to do any fish collecting. So I needed more bottom time. So I had already known Bill Stone. I already knew Bill was working on developing rebreathers. I dug this old letter up. So a couple of years after I met him, I wrote him this letter, and I thought long and hard about my own position with respect to rebreathers, and I've decided that I would like to invest in a Mark IIs. Now, back then, it was the Mark II cislunar rebreather. The S stands for sport. That was intended to be the sport version of the rebreather. I was going to pay for it out of my own pocket. And then further down the letter, I said, by purchasing a Mark IIs, the only model I'd be able to afford out of my own pocket, I could begin taking advantage of rebreather technology while I worked on landing grant money to buy a Mark IIR. That's how we scientists work. We get other people to buy our toys for us. I see great things on the horizon for biological twilight zone exploration when your rebreather becomes available. So this was actually my transition from open circuit mixed gas to rebreather. So a couple of years later, Bill invited me over to his house in Washington, D.C., and Kevin Gurr and I, and a guy named Jim Booth, spent 10 days basically in Bill Stone's garage, tearing down what was by then the Mark IV rebreathers and learning how they were built, introduced to lithium hydroxide and its various uses. This picture was taken by Kevin Gurr, and he actually put me up to the photograph. One thing I noticed actually about this photograph when I was putting together this PowerPoint presentation is it wasn't just rebreather technology that Bill and I shared at the time. We both actually apparently had the exact same taste in timepiece keeping. So we used these Mark IV rebreathers in Hawaii and elsewhere to start exploring these deep coral reefs, seeing what we could find down there. It was a much better technology. If you just saw Simon Mitchell's talk, you know all the advantages that rebreather had. These were prototype-ish rebreathers at the time. They were big, they were bulky, but they were very, very, very well designed. And it solved our problem of time. We now had multiple hours we could spend underwater, divided between bottom time and decompression. And that is basically what introduced me to the world of rebreathers. So using these rebreathers that were designed for freshwater cave diving, naturally when I applied them to our environment, which was a completely different sort of environment, we had new ideas, new thoughts, and this essentially turned me into a rebreather designer. And I spent many, 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 many hours thinking about how it could be improved for our environment. And so that's when I began my collaboration with Bill, which continues to today, coming up with new ideas about how to make these rebreathers better. The Mark IV evolved into what is called the Mark V. That was the first production release that was available. Only 9 of the Mark IVs were ever built. There were actually only 4 built as dual redundant rebreathers, but we ended up splitting those into 9 separate ones. And so this was the prototype Mark V rebreather. I think it was taken in 1995 at one of the tech diving conferences. And this is when I became very intimate with rebreather design and testing. Other people got even more intimate with rebreathers. This is Kevin Gurr. I took this photograph. So over the next 10 or 12 years or so, we ended up using these rebreathers all over the world. I'll show you a map in a little bit about where we went, but it was a real workhorse, the cislunar. That actually on my back there is cislunar serial number 001. It's the first one ever made. It's in my garage still, and I've used it as recently as February of this year. But as many of you know, we started actually switching over to the next generation of technology. Now, Bill and I and Nigel Jones and some others have been involved with Poseidon for the last 5 or 6 years, developing their recreational rebreather. If you search on the web, you'll find some interviews with Bill and I taking a DEMA a few years ago, and we made it very clear that our interest in this was, it was an intellectual challenge to build a recreational rebreather, but the reason we were doing it is because we were interested in the next phase. Some of you may have been in the press release yesterday where Poseidon introduced their tech line of rebreathers. We've been using them now and testing them. This photograph was taken actually last week in Indonesia, 100 meters deep with their tech unit, one of their prototypes. We also used them in Moorea earlier this year. So we've been using the new Poseidon tech rebreathers to replace the Mark Vs. I still have the Mark V, but it's getting old. It's also very, very big and bulky. John Earl, who's my longtime rebreather dive partner, says the Mark V wears you, but in this case, we wear the rebreather. So actually, this turns out to be a much more convenient way to do these dives, and it's actually kind of exciting. As I mentioned, these are the places we've been over the last 25 years, taking mixed gas technology to explore the deep coral reefs. There's also another star that would be over off South Africa. Last year we went and dived with coelacanths. That was a lot of fun. But most of our work has been concentrated here in the Pacific. And our focus has really been about fish. Again, I'm not a rebreather nerd, at least not by choice. I'm a fish nerd. The rebreather to me is a tool to gain me access to the habitats that I'm interested in studying. And what you're seeing coming up here is actually just a subset of the new species of fishes that we've found during all of these expeditions. We're finding lots and lots of new species. We're up to now 12 new species per hour of time we spend at those depths. We found well over 100 species already. We're finding really amazing and interesting patterns that we weren't expecting, biogeographic patterns. Species in these deep coral reefs tend to be much more endemic than the shallow reef fishes are, and a few other really, really interesting patterns. I'm going to take a moment real quickly just to point out this one fish over here in the upper right corner. That's a species of fish that is named Chromis DeGruy. It's a new species we discovered in 2007 while diving for a BBC production called The Pacific Abyss. The host of that expedition was a guy named Mike DeGruy, and Mike DeGruy did a dive dedicated to try to catch this specimen. He used to be a fish collector before he was in the filmmaking business, and he failed miserably trying to catch any specimens. But he did so having so much fun and with such good spirits that when we did later catch specimens, we ended up naming this Chromis DeGruy in Mike's honor. And what we wrote in the paper was we named this fish DeGruy in honor of Michael DeGruy in recognition of the enthusiasm and dedication he exhibited while failing to collect any specimens. The reason I took that aside is that some of you, if you know Mike, he was a rebreather diver, a really, really fantastic guy. He died in a helicopter crash earlier this year, and there's a memorial service going on in Hawaii today that I actually wish I could be at, but I'm here instead. So I just wanted to make a little call out to a very good friend of mine, lost friend, Mike DeGruy. Deep rebreather diving, deep diving wasn't the only advantage we discovered with rebreathers. It also, if you're interested in studying marine behavior, is a very, very powerful tool for certain kinds of organisms in particular. This is a frame from a video clip. There's a whole story behind this about how this is John Earl and I sat here and watched these squid for half an hour having sex, laying eggs, and then all of a sudden they took off. We thought they were done, and then a scuba diver swam by, and then as soon as the scuba diver was long gone, all the squid came back and resumed what they were doing. The scuba diver never had any idea we were there, never would have known. I've seen more fish sex on rebreather diving, and in fact on my first 2 rebreather dives than I had in my entire diving career up until then. So it's not just about deep. So I thought I'd take a moment to think about the things that have changed since Rebreather Forum 2.0. I guess that was, 16 years ago. I don't know if you can still get these. This is the proceedings from that workshop. I actually dug it out of my library and started looking it over last week just to remind myself. And there's a lot of really amazing, good information that's still very highly relevant today. I wrote an article in it, and in those articles I laid out 4 points that I thought were really critical back then, thinking in terms of rebreather diving. that a rebreather diver should know. The golden rules in my mind: one is know your PO2 at all times. Another realization that I had that wasn't obvious before I started is that open circuit scuba experience is not useful for rebreather diving as much as a good grasp of diving physics and physiology. And back then, it was my impression that training should emphasize failure detection, manual control, and bailout procedures. One of the things I always used to tell people back then is that the fundamental difference between rebreather diving and scuba diving is in scuba diving, you have to know how to solve problems. In rebreather diving, you have to know how to solve problems, but more importantly, you have to recognize you have a problem that needs solving. That's the insidious nature of rebreather failure modes that aren't so evident with scuba. And then this is my fourth point, and basically what that one boils down to is make sure you have an alternate way to get back to the surface. So these are the points I came up with back for Rebreather Forum 2.0. I've been thinking about how things have changed. I actually wrote a piece for Kevin Gurr's recent edition of his book called, this was from an article called A Learner's Guide to Closed Circuit Rebreather Diving. I wrote a sort of a 12 years later perspective on what's changed, and I was kind of surprised not much has changed. But there's actually one thing that really has fundamentally changed, and it's only changed in the last 5 years as I've been working with Poseidon. Back in 1996, I was using mostly Mark IV rebreathers, prototypes, and Mark Vs, and strictly for technical deep diving. And there were about a dozen cases over using those dives where during a dive, I and the rebreather disagreed about something, usually about what the PO2 was. And in every single case back then, I was right. The rebreather was wrong. So that sort of led me to this conclusion, which I was quoted in an interview with Walter Comper back at around that time. The only computer that matters for a rebreather is the one inside the diver's skull. The thing that's changed me about that is that over the last few years, I've been test diving a lot of this next generation Poseidon rebreather that Bill and I have been designing. And there have been about a half dozen cases where the rebreather and I disagreed. And every single one of them, the rebreather was right. I was wrong. So that's now sort of reshaping my perspective on this. We may be now on the cusp of technology where a well-designed sensor validation system is actually more reliable than a well-trained rebreather diver's brain. It's either that or I'm getting senile. It could be the latter. But in any case, we're finding that I'm now putting much more faith in the rebreather electronics than I used to. So this is something we're going to be hearing a lot about over the next few days. What are the real risks of using rebreathers? You're going to hear about all these kind of things. We've been thinking about them for 25 years or more, actually, far longer when people started inventing rebreathers. What is it that makes rebreathers dangerous? Some of these things we used to think were really scary and turned out not to be so scary. I don't know of many people who've run into the caustic cocktail problem. That used to be one of our biggest fears back in the day. But is it CO2? Is CO2 what's killing people? There's an argument to be made that that's that. Is it PO2? And even more fundamentally, what is the rate of accidents on rebreathers compared to scuba? You'll see some really good data about that over the next few days. But you're also going to hear something more and more, which is that we don't have enough data. So what I want to talk about now is what I see as sort of the maturation of a community and an industry. And the community and industry I'm talking about is specifically the non-commercial, civilian rebreather diving world. I'm not talking about military rebreather divers who have had a long experience and have a certain paradigm, commercial diver rebreather context. I'm talking about this thing that sort of started out with technical diving and is now morphing into recreational diving with rebreathers. And it seemed to me that at Rebreather Forum 1.0 in Key West, when we were all there, rebreather diving was really in its infancy. Only a few of us at that workshop actually used rebreathers on a regular basis. We had just started using them. We really didn't know entirely what we were doing back then. We talked to the military guys. We talked to the commercial guys. We learned what we could. Rebreather Forum 2.0 is when I think this community of ours was entering adolescence. We sort of had now a track record. We'd been using them for a while. We understood some context. We had the right people in the room together. We learned what we could. And we began, as any adolescents, we knew much more. We thought we knew much more than we actually did. And the point about this is what I want to make is I think right now we're on the cusp of adulthood in our community. It's time to actually put behind us making decisions based on anecdote and making decisions based on superstition and hunches and whatnot. And we need to actually transform this into an adulthood kind of thing, a responsible, objective approach. And specifically what I want to talk about is what actually I do for a living. I wear many hats. A lot of you know me as a rebreather diving guy. You now know me as a fish guy. Those are two of my worlds. But the world I actually get paid to do is to develop computer database systems. This is my office in Hawaii. You can see the only windows are the ones designed by Microsoft. I'm surrounded by LCD screens, and I spend day after day after day after day working on computer database systems and developing international standards for data exchange and biodiversity. So naturally, I'm thinking about data a lot in my life, and I apply that, of course, to fish in my science, but also to rebreathers. So I think the theme of this forum over the next few days, and I hope it ends up being this way, I have a hunch it will based on some of the emails I've seen about talks that are coming up, is that it's really about data. That is the big hole we need to fill right now. And by data, I mean several things. First of all, I mean rebreather black box log data. This is incredibly important stuff. The early cislunar rebreathers logged about 670 events per hour of dive time. The latest version of software on the Poseidon Mark 6 logs between 15,000 and 25,000 events per hour of dive time. I manage a database for that that's got over 55 million data points from 4,000 dives, and that's just from the test divers, pretty much. When those rebreathers, as those rebreathers are being sold to more and more people, there's enormous amounts of data being generated. We need to find a way to make those data translate into better understanding of how rebreathers work on a community-wide basis. These data are incredibly valuable to the diver. I've learned more from reviewing my own dive logs and watching PO2 changes and things like that about rebreather diving than I ever could have from any book or any instructor. It's incredibly valuable to the manufacturer. I mean, I've spent many, many, many hours over the last few years reviewing these data to understand how sensors work, to figure out how to improve the design of the rebreathers. They're incredibly useful. And they're also, of course, very valuable for accident analysis. If you have this high-resolution data, you know a hell of a lot more about what happens when an accident occurs. So beyond just the black box log data from actual rebreathers is just the general rebreather dive data. And by this I mean, actual dive logs. Who's using rebreathers? How are they using rebreathers? How many times are they doing rebreathers? This, again, is valuable to the manufacturer. It's extremely important for understanding how customers are using your product. But to me, the really, really important thing about these data is that it's valuable for accident analysis. You're going to hear this word denominator a lot over the next few days. We know a lot about, we have a pretty good log of rebreather accidents. What we don't know is what context those accidents are happening, what the denominator is, what proportion of dives lead to what kinds of accidents. So if we had, what we need is a system to sort of have a better sense for how much rebreather diving is actually happening out there. We need industry-wide data standards. I think you're going to hear about this in a couple of presentations over the next couple of days. We need interoperability on shared network. For example, if we had sort of common standards about how rebreather networks work within a control system, you can have third-party add-ons that you plug into your existing rebreather that allows it to use the data. And I'm not just talking about like a secondary controller or a fancy heads-up display. I'm imagining things where you can tap into your rebreather's network and pipe your depth data to a video camera. So you can overlay video depth data on your video as you're shooting, and that sort of thing. I think Bruce Partridge will be talking a little bit about this later. And also, we need industry-wide data standards for reporting and content standards. This is the world I live in the biodiversity world, is standardizing all this data and making it so that you can harness it and bring it all together and put it to good use as a community rather than just as an individual database. And what that leads me to is something I'm going to propose. I've talked to Dick Van about this for a couple of years, and I've been thinking about it for a couple of years. And I think this forum is the opportunity to really push hard for it, is to have a shared community database, hosted and administered perhaps by Dan, work out the details, where all the manufacturers and all the rebreather divers can essentially rally around and gather their data together. So I'm imagining the kinds of data that would be hosted here would not necessarily be 15 to 20,000 events per hour of dive time. You don't need that level of granularity for the kind of data the community needs. What we're talking about is maybe averaged values for each minute of the dive. Essentially dumb that data down to just sort of basic information about dive profiles. The data would be anonymized, and by anonymized what I mean is that an individual diver wouldn't be identified and linked to who that person is, but they would be represented by a unique identifier so that you could see within this shared database who, a single person made these 7 dives. You wouldn't ever know who that person is, but you probably would need to anonymize it to get people to be willing to contribute it. Minimally, we would want the basics: time, depth, PO2, water temperature, alarm states in the system. Optimally, we would probably want a lot more than that. This is a conversation that needs to happen among manufacturers and Dan and other people with experience in this world, but I want to see this move forward. And there also needs to be a shared community dive database, not just the log data from the rebreathers, but what's going on the actual dives, with an emphasis on what was the outcome of the dive. One would like to hope that the vast majority of cases, they were uneventful. It was a successful dive, the diver felt great. But the point is, you need that denominator. You need to know how many dives are successful so that on the few cases where they're unsuccessful, there's an accident, a fatality, you have a context to put that in. So I'm imagining something modeled after Dan's Project Dive Exploration, which they started a bunch of years ago for regular diving, open circuit diving, dive computer data. I would like to see something like that built in our community for a rebreather diver. This, to me, is the take-home message, I hope, that will come out of the entire rebreather forum here. So I'm going to close with something. This photograph was taken a while ago, and I would like to say, just as a sort of a personal comment, that if you want to make sure you have a long and fruitful and healthy and safe rebreather diving career, you need one of these. And I don't mean one of these, I mean one of those. My rebreather habits changed more dramatically after I became a father, this is my daughter, than anything else. And so I do point out that it really is about safety. I mean, it really is. This is really what the bottom line should be about for the manufacturers, for the diver, for the community in general. My daughter was 4 days old when this photo was taken. This was literally the day after she came home from the hospital. And because I've tried to learn from my own experiences, I've survived, and she has now, 17 years later. The rebreather's gotten smaller. She's gotten a lot bigger. But life goes on, and I hope for all of our sakes we can do that for all of us moving forward with rebreathers. So thank you very much for your time. I appreciate it. So we're running a little bit late on schedule. If someone has a couple of particular questions, I'll be glad to take them, but otherwise we'd like to probably move on to the next talk.
Roy, right now, Dr.
Okay.
Pyle, did you say you were finding 12 new fish?
Oh yeah. 12 new species per hour is our average. That's our average. Shallower than that, it's more like 8 to 10. Deeper than that, it's upwards of 22.
Okay, that's pretty amazing.
It is pretty amazing for fishes, yeah.